Good morning, all of you. Uh, Welcome to this webinar on SOLIDWORKS MBD, an integrated drawingless manufacturing solution. I am your presenter Vishal, and I'll be taking you through this complete presentation on SOLIDWORKS model-based definition. So let's get started. I'll start with an opening remark from one of our customers. They say, in the past 20 years, all our CAD investment, either 2D or 3D, were just to make a faster and better 2D drawing. At the end of the day, is that good enough? Is that all we can do? Or can we do better? That were some of the queries asked by this customer. The customer name is Tyco Electronics. Okay. MBD. MBD is hot. Uh, we didn't release any public announcement until September 2014, but many of our customers have been asking us about what SolidWorks is doing on MBD. What's your plan of improving Dimension Expert? And these are not just North American customers. We have global customers like GE and Baker Hughes, European customers like Raphael and Patek Philippe, and APAC customers like Hui asking these questions. Some are piloting with MBD using Dimension Expert like G Measurement and Control Group, who set a goal to put 20% of the fabrication on MBD this year. Some already established digital factories powered by SolidWorks. Okay. So what is MBD? PMI, a standard for, it stands for Product and Manufacturing Information, including datum, dimensions, tolerances, bill of materials, notes, surface finish symbols, well symbols, and coordinate system. MBD's full form is model-based definition, or it's known as MDE as well, which is model-based enterprise. So what is MPD? The best way to explain it is to walk through the real manufacturing case instead of an academic definition. Let's say we want to machine this aluminum bracket or a donut. Okay. So best way to do it. The best way to do it is to let's say we want to machine this aluminum bracket. So build the model in SolidWorks, cut the aluminum stock. Okay. So I'll just show you the process. Build it in SolidWorks, cut aluminum stock, go through all the machining steps. Okay, and then we have a finished product, right? From 3D design to 3D machining to 3D product, very intuitive and streamlined process it seems, right? But wait a second, are we missing some critical product and manufacturing information, PMI, such as dimension, tolerances, surface finish, and so on? In order to convey PMI, somebody in the history invented 2D drawings 100 years ago, which works well. But design and manufacturing are in 3D, so why not the PMI? Okay, so 2D drawings are counterintuitive, involving lots of coding and decoding, mental reconstructions of the 3D object, which leads to extra cycle time and errors. So the gist of MBD is to marry the advantage of 3D modeling and 2D drawing into one 3D master document to guide the manufacturing process. So the answer is MBD, SolidWorks MBD. We are going to see a detailed presentation on this later on. Okay. We start with the problem. What are problems with 2D drawings? The manufacturing process is complex, involving 3D design, 2D drawing, operating method definition, procurement, fabrication, assembly quality, supply chain management, and so on. However, 2D drawings turn out to be very time-consuming and expensive process. Regarding the collaboration between the DoD engineering department like AR, PEC engineering, and the supply chain, 1/3 of engineering dollars are spent creating and maintaining 3D drawings. Yet 60% of them don't match 3D models. Okay, just hope everybody can hear me properly. If you have any doubts, maybe you can just type in your message into the chat window if you can't hear me properly, or if you have any technical glitches. Okay, so let's continue. This estimation is confirmed by some other commercial customers as well, such as G and FTS. Sounds About right. We have the same problem. The exact percentage may vary depending on customer, but the problems are relevant. Another perspective of a problem. Let's see. One is the BA system, that is a ground combat vehicle of US Defense Department. The other side, all paperwork to fulfill define this vehicle, such as part drawings, assembly drawing specification, bill of materials, QA provisions, inspection report, maintenance guide and product manual, and so on. Guess which is heavier?
Right.
Can you guess? Turn out that all paperwork to defense BAE system vehicle heavier than a huge vehicle itself. You can see the paperwork is huge. Textron also made a similar comment. There's a customer in US, Textron. Every time we ship a product, we have to ship truckload of paperwork. We hate it and we don't want to do it anymore. Nobody wants.
No, the great
So MBD is not new. Its concept was thought about 20 years ago. But why we are discussing more about it now? Okay. It's like DoD is pushing hard on MBD. A new military standard was released in early 2013. Fiscal year 2014, MBD is recommended deliverable format for all DoD suppliers. It's a huge advantage in winning contracts. DoD, along with other large enterprises like Boeing and Ford, are generating the ripple effect, driving the adoption through all their first, second, and third, and downstream suppliers. The other timing factor is 2D drawing are less and less taught at schools nowadays. This is a Joffrey Moore bell curve. Summarizes the typical technology adoption trends from inventors to early adopters, early majority, late majority, and laggards. Laggards mean people who make progress very slowly. This is generally applicable to technologies like personal computers, 3D printing, smart devices, and so on. Putting this curve into a SolidWorks customer base perspective, regardless drawingless manufacturing, the adoption has jumped from 1.5% in 2009 to 16% in 2013. You can see there's a huge growth there. Also, the 16% is a tip point right before this technology becomes a majority technology. These are some of our customer comments on MBD. One is AS and E. We send a lot of 3D PDF to our vendors. To our surprise, the supply chain vendors hadn't had any problems, says the senior designer from that company. Our customers, aerospace and defense, that is Cubic, says we are currently requesting both MBD document as well as 2D drawings from our vendors. Okay, so you can see MBD is growing faster. Why are we out? Okay, I think there are some background voices that we can hear here. So let me mute all of them. I've already muted. Let's. Okay. Sorry, let me mute all of you again. Okay, I think now you can check once if you can hear the voices still. Can you still hear the voices? I think okay, it's clear now. Thank you. I think some of their microphones were on, so I have muted all of you now. Okay, so great. So again, if you have any query or something like this, you can just type in and we'll take care of it. Sorry for the inconvenience caused. So let's get back to our presentation. Okay, why are we outstanding? Why is MBD outstanding? Let me give you a few points on this. We have outstanding 3D PMI definition and organization capabilities. We have an intuitive user interface based template customization. We have solid industry standard compliance. So let's take a look at all of these. So till now I was just talking about MBD. Let me show you what it is actually. So let's jump to our SolidWorks quickly. Okay. So SolidWorks MBD provides an integrated drawingless manufacturing solution which helps you define, organize, and publish 3D manufacturing information and 3D model data into industry standard file formats. Uh, Manufacturing intricate components with precise fits can be a complex and time-consuming process. Creating drawing takes time, but communicating your design intent clearly and maintaining detailed multi-sheet drawing is more challenging these days. SolidWorks MBD lets you apply all your manufacturing information directly to your model, making it easier to define but also easier to understand. In an assembly like this, which is an underwater camera housing where precise fits are required to prevent water ingress, and where these gears need to mesh accurately to control the zoom and focus. Every part needs to be machined to a very high and tight tolerances. This can mean again high cost, but carefully considering geometric dimensioning and tolerancing can actually lower cost in some cases. So GD&T is not just for close tolerance parts and assemblies, it can be applied to any part. The process of setting up a detailed 3D model is straightforward, starting with considering how this part is assembled. Okay, you can see this blue gear plate is mounted on the base plate here. Okay, I can show you with some 3D views to give you a better idea. Okay, so I've already created some views here through MBD. Okay, you can see it's mounted on this plate with these two bolts. With this in mind, the gear plate needs to be dimensioned in such a way as to ensure the gears mesh correctly and the whole assembly works as expected. So you can see we need to take care of that, and there should be all the proper tolerances should be given to this blue gear plate, right? So let's take a look at this gear plate itself. Okay, so you can see this is a gear plate, and I have this gear plate, and I have made some views in advance using MBD. So you can see there's a new functionality, there's a new tab that you can see at the bottom. Again, let me tell you, SolidWorks MBD is brought in from SolidWorks 2015 Service Pack 2 and the versions which are there ahead of that. Okay, so I've created some views in advance. So there's this view, and there's a view called overview. Okay, uh, so let's say I'll activate this overview, and I want to put some notes in here. So what you can do, you can have some text made already, and you can save them in your design library, so you can use them every time you want them. So let's say I'm going to use this text file here. Okay, let me bring it properly. You can see this text again is not a dumb text. You can link material and mass with some custom properties that you have created. So you can see I can just link that to a material. You can see my node will have the material which I have linked with my part now. So if I change any material there, it will be updated in this node. You can see when I have created this node, uh, in this particular overview, okay, it will be shown only in this particular view. If I go and activate the other view, it won't be there. If I go to that overview, you have the node which is available. Okay, so that is a method like how we are going to use MBD, and we are going to create all these views. So let's start with the ISO view. You can see I need to dimension this particular gear plate here. So I'm going to use my dimension expert. So let's go. You all know dimension expert. Okay, to dimension these automatically, I need to select some datums. As we all know, we'll start with the auto dimensioning scheme here. The part type I'll tell as is prismatic, and the tolerances that I'm going to use are the geometric tolerances. So the primary datum that I'm going to use is this base, because it's like this is resting on that base plate. So I choose this as a primary datum. Secondary datum, I'll choose this bearing bore as a secondary datum. For tertiary datum, I'm going to choose this hole. Again, you can see this hole is I can show it continuous because it was drilled in a single go. So I choose these three datums, and the feature that I'm going to dimension are this pattern. You can see as soon as I select this, it understands it's a pattern of 2, and it selects as a pattern. SolidWorks dimensioning is pretty smart enough. I'll select this feature as well and just say okay to it. So as soon as I do that, it will dimension all this. Okay, you can see it's dimension. It has dimension all these features properly. Let's just go and orient this model properly. So I'm just going to orient it in a top plane. So you can see there's one of these dimension there, but the dimension which are required to position these are not there. So what I can do here is I can go there. We have a nice tree display. There are different options. So I'm going to show annotation based tree. So it will show me all the datums and it will show me all the dimensions which have been applied uh, just now. In this, I'm going to choose that and I'll right click and I'll say create basic dimensions. Okay, so as soon as I do that, it automatically creates the basic dimensions for me, defining the positions of those holes. You can see this is only having two dimensions because some of the dimensions it has placed in the other view. So I'll just quickly go and show you like what those other views are. Okay, let it place. Hope everybody can hear me properly, everybody can see it clearly. Okay, so you can see I've just made use of this position and I've created these two basic dimension. I'm just going to orient it properly. Okay, waiting for those dimensions to be added properly there. Once it's done, okay, I can see some questions coming up. Okay, you can ask these queries at the end of my presentation. Okay, there's a question tab out there. Okay, as soon as this presentation over, you can just put in your queries there. Okay, if you have any doubts, you can type in into the chat window. Okay, I think there is some technical thing. I'll just come back. Just give me a minute. Okay, sorry for the inconvenience caused. We are back again. Okay, so sorry for this. There was some technical glitch. Okay, so we were here. I'll just start from there. Again, we can see there is a display tree. I have this dimension where I can just select that and I can recreate some basic dimensions. You can see some basic dimensions like this to create the position for this two holes. Okay, there are some dimensions which have been created in this view as well. You can see this dimension number 4, 3, dimension 3 and dimension 4 is created here. So what I can do, I can just select and I can make it in the top. I can assign it in the top. So if I just go and reorient it, so you can see all those dimensions will be in this particular view. So dimension number 4 and dimension number 3 is also brought in this same dimension. So I can just align properly. And once it's aligned, uh, let's click a 3D. We'll capture this view. I want to have only the annotations which are there in this top view, so I'll just select only that and say OK to it. Okay, so and it's done properly. So let's quickly go and orient the front view. You can see there are certain dimensions in the front view as well. uh, I want the location of this hole as well, so I'll just quickly go there uh, in this position and I right click and I'll say create the basic dimension. So you can see it automatically creates the basic dimension for me. Again, a good way to align the arrows properly is to just click on that. You can see you'll get a proper diameter arrows which I can do it properly like that. Once it's done, orient it properly. Again, I can just go there front and orient it, and I have all dimension and click to capture a 3D view. So you can see I can just quickly capture a 3D view. I want only the dimensions which are there in front view to be shown and say OK. In this you can see there is a pattern. There is a circular pattern of this hole. I need to dimension them as well. So for that, what I'm going to do is I'm going to go to my dimension expert. In this case, I'm going to use the plus or minus tolerances. Okay, in this I'll just make use of the primary datum of using this bearing bore. The feature that I'm going to like dimension are these circular pattern holes. As soon as I select one, you can see automatically understand it's a pattern and it selects all of them and just say OK. You can see as soon as I select that, all the holes with their position, everything is defined properly. I'll just orient it again in the front view. You can see there are some more dimensions which are added with the details of the hole, like how many holes are there, what is the depth, what is the diameter, everything has been captured. At what angle they are placed, you can see the angle as well, and the pitch also has been defined here. So you can see all these dimensions are defined for that particular pattern of holes. But what I want is I want to place these dimensions into a separate view to define this whole pattern. So what I can do here is I can go to annotation and I can say I want to insert a new annotation view. In this case, I'll take a reference view as a front view and just say oh, next. So the annotation that I want to move from that view, that front view, to another view is I just need to select all those annotations. So I'll select these three and say OK. Once I do that, I'll capture this 3D view. Okay, I can make a new, I can give it a new name saying that it's a whole pattern, and I can say OK to that. Okay, and you can see we'll have a new view. The front view is there still, okay, with all these dimensions, and I have a new whole pattern which shows only the dimensions for that holes which are patterned in circular manner, right? So that is a good way. Again, now let's go and see few more views how we can create. For that, I'll just activate and reorient this model into the right plane. So I've just oriented it like this. So I can just capture the dimensions here in right, and I'll keep everything in right. So I'll say OK to that. So you can see it has been captured. MBD has captured that right view. Now let's start dimensioning this. So to dimension, I can make use of my location dimension and size dimensions. So first I'll make use of my location dimension to add few dimensions here. Let's say I'll choose this face. Again, I know this is a part of the same face, so I'll make it one face. And let's define this particular thickness there. Okay, you can just add some tolerances. I'll just make it as a limit. Say OK to that. Again, let's add few more dimensions. I'll choose that face and that face, and let's add that dimension there. Say OK to that. I'll just give some height for this feature, place that dimension. Okay, again let's go and add this thickness. Okay, once you are done, you can just go and see, you can see all these dimensions are getting captured in the right view. Okay, you can even add some size dimensions like this fillet. I can give this this is the manual way of doing it. We have seen the automatic way as well. Or this chamfer, I'll place it here. Okay, there is one more dimension that I want to add, so that is the location dimension. You can see as soon as it's like that, I want some dimension between these virtual shops, so I can just create some intersection there. So say I want the intersection between these two, and I want the intersection between these two faces, where I can add a dimension. So you can see as soon as I add this dimension, there are different ways of adding this dimension in direction. So it can be a vertical dimension, it can be a horizontal dimension, it can be a neutral dimension. Sorry. Again, it can be user defined with respect to some references. In this case, I'm going to use place it as a horizontal dimension here. So let's place it properly. Once you are done, let's orient it in the right way, align it properly so that I can see all the dimensions there, and we have all these dimension placed in the right view. Okay, so this is a great thing to do. You can see whenever you create any part, you define some we define dimensions. Those are our model items or reference dimensions. Okay, so I'm going to show you one example of that. So for that, let's go and orient it in this left view, activate and orient it. In this view, I'm going to activate my feature dimensions. So the dimension that I've given to my feature, so that are unassigned, so I'll show all of them. So you can see there are some dimension that I've defined here. So what you can do is, like, you can just go on select those dimensions. I can go and select all the dimensions which I want. Okay, and I can, sorry, okay, and I can put it in the left view. So as soon as you click the simple tab here which activates this annotation view, you can choose where you want to place them. So I'll place all of them in the left view, say okay, and let's hide this one. Okay, let's go and say hide dimension expert as well. So you can see the dimension that I've selected in this particular view, I can just capture it in 3D. So I'll make it as left, and I'll keep all the dimensions which I want it in left view only. So you can see it's how easy it is to capture the dimensions which you have given to your features as well. Again, there might be a case where let's say I'll activate this right view, and there might be a case where you have multiple configuration in your model. So how you're going to deal with it? So what I can do, I have a lighter version of this gear bracket, so I'll just go to that and I'll activate that. So you can see I have this lighter version. In dimension expert, we can copy the complete dimensioning scheme from one configuration to other configuration as well. In this, my source configuration is default, so I choose that, say okay, and whatever dimensions I had in default, I can bring it up here. So some dimensions dangling, I can just go and delete them. I don't want them to be shown. Say okay to them, because some changes have been made there. Okay, and I'll just go and capture the view, and I'll put it in the right view. I'll name it as version 2. Version 2 for that. Say okay to that. Okay, again, you can see if I orient this model in this way. Okay, so there are some dimensions which are not there, like there are some holes which are at the back end. Okay, I'll go to my all dimensions. Also, you can see now all the dimensions in your ISO view. Okay, there are some dimensions placed in different view. Okay, but I want to give some dimension to these holes which are hidden. So what I'll do, I'll just activate this. Okay, in this case, let's go and orient it in this particular view properly. Okay, let's have a section view there. Okay, I can have this section view. And once I do that, I can create a new annotation view here. I'll capture it. Okay, and I can give it as an inner holes name. Say okay to that. Okay, so I have only inner holes. I want to add some more dimension for these inner holes. Before that, I'm going to show you some capabilities, some options which are there. So you can see you can control all the options like size dimensions, location dimension, chain dimension option. You can set it from here. In this, we have something called a geometric tolerances. You can create the basic dimensions automatically as well in this case. So let's say if you have a size dimension here, let's say you want this to be shown in this, and I'll add some geometric tolerances to it. Let's add a position, and let's give it a diameter and material limit symbol. Let's add a dimension. It's 0.1. Let me define the datums and say okay to it. Okay, as soon as I say okay, you can see the basic dimensions are added automatically there. So the dimensions which are required for these inner holes, positioning of these inner holes are being defined automatically because I chose that option basic for basic dimension in my options. Okay, once this is done, okay, now many of these views you need to send it to your vendors or you need to send it to your shop floor. So many of the companies may be using SolidWorks e-drawing tool for this, or many of them use PDF to communicate this kind of drawing. So how we are going to deal with it? So let's say once you create all of these, and if you want to make an e-drawing out of it, you can just go and simply click e-drawing. Before showing that, there's a beautiful tool here. We call it as a dynamic annotation view. What it does, I can rotate this in 3D. Okay, and whenever I go to that proper near to that proper orientation, it highlights all the dimensions which are there. So what will happen? The confusion will be gone. So for that, let's say I'll activate the ISO all dimensions, and I'll go and just choose that. So as soon as I go in this front, we can see all the front dimensions are activated. As soon as I go to this right view, all the right dimensions are activated. As soon as I go to the top view, all the top dimensions are activated. So it's a dynamic annotation view. It's a great tool to view your dimensions properly. Okay, now once it's done, let's come out of that. Let's activate ISO all dimensions. Okay, and let me go and show you all the views one by one. You can see overview we have where I have placed the nodes. I have a top view where I have placed some of the whole position dimensions and some whole details. Okay, so I want to create e-drawing of all these views. So what you can do is you can just simply go to publish e-drawing file, click on that tab, and I want all the because I have selected one more configuration, so I want all the configuration to be considered, and it will start capturing all the views for me. Okay, and it will create a e-drawing out of it. So let's wait for a minute so that the e-drawing is created. Okay, it will create the e-drawing and it will open the e-drawing as well. Okay, so here we have the e-drawing in front of us, which I have just created. You can see there's a tab for 3D views now in e-drawings. You just open that. You can activate any view out there, and all the dimensions on for that view you can see in e-drawings now. So this is a better way of looking at your 2D drawings rather than looking at a 2D drawing on your drawing sheet which you print. Okay, everything is in 3D here. So even if you are in right view and if you just rotate, it will show you all the annotations which are there in the right view only. Again, there's a good thing about it. Let's say if you click on that, it will show you the reference geometry also for that. So you don't need to worry about it. Let's say if you click on that dimension, it will define like that dimension is specified between what faces. Okay, so that makes your job a bit easier as well. So that was all from the e-drawing portion. Like you can create e-drawings in this way. You can see all the e-drawings are there. All the views are there. Whatever we created just now, you can just browse through every view. Okay, that was e-drawing, but many of them prefer using PDF as a communication tool as well. So whoever wants to create it as a PDF, we have option for creating as a 3D PDF here. Before that, let me show you the templates that you can have as a 3D PDF to create 3D PDF. So you can see there's a template editor inside SolidWorks MBD. So you can just choose different templates. You can see, you can just open a different template. I can just go and you can see there are different templates we have. So we have some assembly template, we have a part template. If I just go and open this part template, so you can see it will show you the main view and the other views. It will show you all the properties which will be captured in that. It will show you the nodes area and everything. Okay, so you can just choose a template and you can create a 3D PDF. So let me show how we can do that. So I'll just go and say a 3D PDF. I'll choose a proper template that we saw just now, and whatever views you want to consider, you can just go and select all those views. You can even see the custom property tiles. Okay, you can see what custom properties I'm going to capture. So it's a drawn by material, part number, revisions and all. I'm going to capture that. Again, I'll just click on view PDF after saving and just say create PDF. So you can see as soon as I do that, it will create a PDF for me. It will first capture all the views and create a PDF that you can use for communicating with your downstream departments. Okay, it will capture all the views for me first, what I have created. So if you are planning to have a paperless drawing process, and if you are planning to have some computers on the shop floor, let's say, and so you'll be communicating with your shop floor people using 3D PDFs, and this is the best tool that you need to have. Okay. Okay, let it create a 3D PDF. Okay, the PDF is ready. Let's open it. Okay, you can see everything has been captured. I'll just maximize that. Okay, you can see the part number that is drawn by, the date, the revision, the material, the mass. Okay, everything has been captured there. If you want to have some suppliers comment, you can just type it. You can just, let's say, the way I'm typing it right now. Okay, I can have some suppliers comment noted there. Okay, you can see all the views. Again, this is a 3D PDF, so I can just go zoom in, zoom out. I can just rotate it. Even I can orient it in a proper way. So if you can just say, I can, if I go to this top view, it will show me all. Again, if I click anything, it will show me the references as well. So I'll just go to this right. I can just click that. You can see as soon as I click that dimension, it will show me the reference geometry as well getting highlighted. So I'll come to know like this dimension is between what. So it's a good way of looking at it rather than looking at a 2D drawing, which is very difficult to interpret sometimes. This is the best way you can make use of SolidWorks MPD. If you're planning to make your office as a paperless drawing office, you can see all the views are placed there. Okay, just browse. This is a configuration that we used. Okay, and you can rotate it in 3D. Again, you can have all the options which are there in 3D PDFs available here. Okay, so that's a great way of looking at it as a 3D PDF, right? Everything is 3D. So let's me close this. Say no. Okay, that was on the part level that we have seen. Again, let me switch back to my assembly level. So I'll just close this part that we just saw, and let me open that assembly that we were like looking at in the beginning. Okay, let me open that assembly. Okay, in this case again you can see there is 3D views that I have. You can again have exploded views as well. So I have made one exploded view already. So I can just make this explode and I can just capture it in 3D. So we have an exploded view captured as well. Say okay, and I captured an exploded view. We can just go to SolidWorks MBD tab. You can say publish 3D PDF. In this case, I'm going to use an assembly template that I have here. You can have all the views that you want inside that. Okay, maybe I'll have a few views just to be a bit fast. Okay, let's go and click on that. As soon as I do that, it will start creating a 3D PDF for this assembly, and you can see all these views like how we saw it for parts. Okay, so by the time it creates 3D PDF, let me quickly summarize. SolidWorks MBD provides easy to use tool for creation, organize and output of product manufacturing information, and really helps streamline production. It cuts cycle time and improves product quality. Okay, so hope you liked this presentation of SolidWorks MBD. There might be many queries in your mind because this is the first time you might be looking at some tool like this. So if you have any questions, please feel free to ask. We have some time now. So first of all, again, let me thank all of you for being here in this presentation, for being patient, and again, we suggest like you keep on attending these kind of seminars that we or webinars that we organize. Okay, so that you can look into the other solutions that we have uh, for you. Okay, so you can see that 3D PDF has been created, and whatever views I have selected all have been captured. You can see there's a exploded view as well, so you can just zoom into it and you can have a 3D PDF like this. Again, you can see there's a bomb as well, and it's an interactive bomb. You can just select and it will show you uh, the components. It's that interact. It's again the other way around as well. You select the components here and it will show it in your BOM. So that is a good way of looking at your assemblies as well. Okay, so thank you so much again. You are free to ask any queries. We have some 10 minutes dedicated for queries as well. So I'll just stop here and I'll give you a chance to ask. If you have any queries, you can ask. See my details here. I have written my phone number. I have my email ID. Okay. Again, if you have any queries that you want to ask me through mail, you can just communicate. You can just write me mail, or you can call me as well. Okay. I love to answer all your queries regarding this tool, SolidWorks MBD. Okay. If you have any queries, there is a question tab. You can see there's a question tab on your webinar window. Okay. You can just go to that question tab and you can write in your questions there, so I can just read them and I can answer them back. Okay, there's a query asking that whether this product is uh, comes with SolidWorks Premium or is a separate product. So this is basically a separate product. Okay, you need to purchase separately, and it will be added work as add-in. Okay, thank you everyone for this. Okay, uh, sorry, there's one query coming up. Let me check that. There's a query asking that can we place multiple views in a single slide? Okay, I didn't get that question clearly, but let me try and answer that. Actually, you can't place multiple views in a single view, as you can say. There are different views that you need to create, and different views will be created. Every view will be separate. You can't merge multiple views into a single view. So whenever you have to create a view, you have to create it separately and you have to save it. Okay. So if you create after that, once you create a PDF out of it, it will show it as a single view separately. Okay, there is a query like how do you define the datum? This seems to be very generic query. It's not related to MBD. Okay, you need to go through some of the dimension expert lesson or GDNT lessons. So there are different rules for defining the datum. Okay. In this case, SolidWorks, we have dimension expert, which you can make. We have dimension expert. We have annotations through which we can go and define the datums. Okay. It's not single slide, it's a single sheet, it seems. Okay, it's not a single slide, it's a single sheet. Okay, that is in continuation with the previous question, whether we can place multiple views in a single slide or a single sheet. So that is a basic difference. Okay, here we are not considering any drawings, 2D drawings. These are all 3D views. Okay, and that need to be created separately. You can't have multiple views in a single sheet as well. That you can have on 2D drawings, okay, obviously. But in this case, you need to create each view separately. Okay, any more queries? Feel free to ask any queries if you have. Even if it's a small query, don't hesitate. Feel free to just put a question. I would love to answer that query. Okay, hope it seems there are no more queries coming in. Anyways, if you have any queries, you can write me. I have given my mail ID. Okay, again, I thank you. Thanks to all of you for attending this webinar. And please be aware that we do these kind of webinars every time. So just keep like be attentive and just keep on attending these webinars. They are really helpful and they will provide a lot of information about all our other products. Okay, thank you so much. On this note, I'll just say goodbye to you. See you again. Bye.